Hi again, it's me. This is the third video now. The last two videos should be floating around somewhere on our channel, so if you want to check those out, feel right ahead. Anyway, so for this one, we're going to do the chloride salt demonstration. It's also been called the rainbow demonstration by a couple people. There have actually been several accidents by this reaction in recent time, I guess. And it's because there were safety procedures that weren't exactly followed to the letter of the law. In this reaction, we're extremely careful in the way that we dispense any of our burning solutions, and in the way that we keep our burning solutions on the desk and how we handle our methanol. So let's take a look. So as you can see, we have several recrystallizing dishes set up. Evaporating dishes. We have several evaporating dishes, pardon my bad, set up across the top of a bench top. And, well, we're using methanol as a solvent. So our very first dish is just straight methanol. There's no salts added to this at all. And you can just see, since it's a dark room, there's this really pale blue flame that's present. That's how methanol burns, and that's all the solvent addition that you'll see with any of these chloride salts. And that's also why this experiment or demonstration can be kind of dangerous, because it's a really pale blue flame. So if you're in a lit room, you can't really see it very well. So if it dies down, you may think it's out. You go to pour out more methanol, it's not actually out. The methanol trail burns the whole way back up into the stock bottle, and boom, you have a giant explosion. So anyway, you can see that we're beginning to pour out these salts, and as you can see, we're not pouring any sort of salt directly out of a stock bottle. We're pouring them out of scintillation vials. And these scintillation vials hold about 20 milliliters of solvent. So as we're pouring these out, we're also very careful to keep them capped and keep them away from any flames, so that there's little to no chance that any flame can travel back up into our vials and cause any sort of explosion that would be harmful to us or any of our bystanders. But anyway, enough on safety. As we go in, you can see we have several salts dissolved into our methanol solutions. So going from right to left as you're looking at the screen, the very first one, as I just mentioned, was methanol. We move one to the right, and you can see it's strontium chloride, which should be somewhere on this periodic table behind me. Yes, there it is. That one right there. As you can see, it's burning with this nice reddish orange color. And we continue through, we have calcium and barium, and then we have copper there, which is this lovely green color. And this video may not go long enough for you to see it, but eventually when copper's burning, we'll throw one up. But it actually will change oxidation states, and instead of burning this nice green color, as you see with copper chloride, it'll actually turn to a nice blue color as it burns. And I'll have to show a video of that after this. And then we go sodium and potassium. As you can see, sodium's this nice cheery yellow color, and potassium's a great violet looking color. So you can see them burning there, and it goes for a nice long time. We use a decent amount of solvent, enough to make our safety coordinator a bit nervous, but then what's a good demo if your safety coordinator isn't slightly skittish around you? So then we move on to our next demo, which is actually chlorates. And chlorates are good oxidizers. It's a O3. And in this demo, what we use are sodium and potassium chlorate.
I can't hold it. All I do is talk.
Anyway, pardoning the interruptions from random members of our peanut gallery back there, make me need to break out more chloroform. Anyway,